Okay, this question is giving me a lot of trouble. Basically, given a string, remove all duplicate letters such that the resulting string is lexicographically smallest. So that basically means if I remove, say for example, an A here, so I get this, that's greater lexicographically than if I remove the second A, because A is smaller than B. So I would prefer this one in this case, but also have to remove duplicate B's. So in this case, it would be best to remove the last one, so to get ABC. And that would be the answer for this. So you can kind of do a greedy solution. If I see a letter like A here, I know I can get rid of, and C and D are not have, their frequency of C and D is greater than 1. That means they appear later on after A, so I can remove C and D. So C, D, A. Before I'd add A to some kind of stack or something, so pretend this is a stack. Before I'd add A, I'd check, can I remove what's already at the top of the stack? So if the letter at the top of the stack is greater than my current letter, so my current letter is A, D is greater than A, so, and also if the frequency of D is greater than 1, and it is, so the frequency of C in this case is 3, C frequency of D is greater than, is 2, is, 2. A's frequency is 2, and we also have B's frequency is 1. So the current element is B, and this is my stack. I'm adding B. If the element at the top of the stack is greater than B and its frequency is greater than 1, it is, so this is the frequency map, then I should remove D and keep doing this until either the stack is empty or we find a letter that doesn't satisfy those two conditions. So in this case, C is still greater than A and its frequency is greater than 1, so let's remove that as well. And then we add the current element, B. We move on to the next element, so we're at, so the current element was A, so we add A, so we were at here, and then we move on to D. So the current element is now D. In fact, I'll just get rid of that. So we can add a D, but we check if the top of the stack is greater than D. It's not, so we can continue. And then we continue on again because we didn't have to remove anything. So now we see an A, but A is already in the stack. In this case, we just want to pass over A because it's already in here. If we were to choose this A instead of this A, there's no benefit in that, because no matter what happens, if I choose this A over this A, like if I just delete this A and just add an A here, this will be either greater lexicographically or the same. So as a greedy solution, we'll just ignore it. So in this case, if I add an A and delete this one, then that's greater lexicographically, so let's ignore it. So to ignore it, I would actually have to keep like a stack, keep like a set, I guess, of elements in the stack so far. So we have A and D. And we have an A so far. Since we see an A is in the set, then just continue. So we're moving on to B. So should I add this B? Before I add this B, should I remove any from the stack? Well, D is greater than B, and the frequency of D, I think we were supposed to decrease. Yes, sorry. We were supposed to decrease it every time we remove something from the stack. So before we removed the D and the C, so this would be decremented. And then we added, we're at B now, so should we remove D? Well, D is greater than B, but D's frequency is 1, so we don't remove it. And so that means we just add B and increment our solution. Okay, we're at C now. At C, B is not greater than C, so just add C. Oh, and I forgot to add to the stack, so B, and now we have C. And now we're at the very last letter, C. We see C is already in the stack, so just ignore it. And there we go. So A, D, B, C would be the lexicographically small. So it's a kind of a greedy solution there. Okay, let's try to code it up. So we have a map of the frequencies. So an unordered map would be best here. A char to an int. So the frequencies, and we also have an unordered set of characters char. So in stack, and we also have a stack. So I like to use a vector instead of the stack because the vector is a little bit more flexible and supports everything a stack does. So we have a char for the stack, vector of chars, and this is the stack. And let's call it stk. So in stk. Alright, and then now, before I do anything, I want to count the frequencies. So I want to go through for or char C and S. Frequency dot S, increment that. Okay, and then I want to go through all the elements again. And this time I want to say, if C is already in the stack, so if in stack dot find find C is not equal to in stack dot end, so that means it's already in the stack, so if we want to continue, just ignore it. So, and while in stack, so while the stack dot size, so while there is still something in the stack, and stack dot back is greater than my current element, so C, and the frequency of stack dot back is greater than 1, I think. Yes. Then continue removing things from the back of the stack. Yeah. So remove it from the stack, and that means I need to decrease the frequencies first, and then do stack dot pop back. And then I need to make sure I add the current element to the stack. So I need to do stack dot pushback. C. Is that it? And at the end, return. Okay, so in the stack, let's just call it answer, to be honest. And let's just make it a string, because then I can just return the answer. This would be better. think that works. Let's step through it. So we're going through, we've counted the frequencies, we are adding each element one at a time. We have C, D, you have A, okay, and we're adding that. Alright. I think that should do it. Okay, cool, so that works, and let's see if it works for this case here. I forgot to add to the int stack. So since I'm pushing back something, I want to make sure that I am adding to the stack whatever is insert C and then push back. But when I'm popping off the stack, I also want to remove if it exists. So let's see, erase. So let's see if I can do unordered set C++ erase. Auto it is equal to instack dot find answer dot back. If iterated is not equal to instack dot end, I want to do instack dot erase. It. In stack. Okay, so that seems to work. Let's try that out. Wait, really? Okay. Let's see what's wrong here. So we have, if I were to do this question, I would add the B. I see a B already, so I skip it. Then I see a C. Yep, add it in. I see an A. I will replace the A because our C has a frequency greater than. Oh, this B here. Since I'm skipping over it, I'm essentially removing the frequency. So I need to decrement the frequency if I'm skipping over it. So I need to do frequency of C decrements. Hopefully that's it. Okay, awesome.